So normally this image which shows you what the computer vision is. So you may always think, what is vision? So every human being is having a vision. Oh, so then why you're calling it as computer vision, the new technique? So here you are giving vision to a computer, right? Exactly same as a human being. That's what computer vision is, right? So if you take for example, whether my screen is visible,
Yes, sir.
okay. So take for instance an image like this. So we are able to see a image, a person there in a form, right? But what the computer sees is series of integers, right? So what we have to do is you have to make the computer to understand from this series of matrix of real valued numbers, so that the computer understands this, that's a person there, right? So this is what the computer vision will do. So here, what the computer vision for our vision, what you do is we'll see using our eye, will capture the object, and we'll use the brain to interpret what the thing is and what are the available matters there, right? All these things you are able to interpret and give it as the output, so which we will have, right? So some disturbance is there, right? So next we will go to computer vision. In computer vision, what the main goal is, so we will use a device that is normally a camera. So using that camera will interpret, make the computer, it is given to a computer where the computer will interpret what the output is, right? So this is what nearly what is computer vision. Uh, Here we are able to sell a story. So suppose if a image is given like this, right? So we are able to tell a story using that. So there is some accident has occurred in railway station, right? Likewise, we are able to tell the story. So this image we take it in 95. So, but when when you give it to a computer, but the computer can understand, but you are able to tell a story here, right? So what the thing is, your main goal of computer vision is to write computer programs so that it can interpret the images, right? So that will interpret, so this is the image, right? So this is what we have. We have to write a computer program. So it's not our thing which can be done artificially. We can naturally. So we have to do artificially. You have to write a program in order to interpret the images. Suppose can computer match with human vision? So everybody will ask. So you also may ask it is whether it is yes or no. So mostly you'll tell it as no. It cannot match. Oh, so humans, so when you go for humans, they are much better at hard things. Hard things means, so they're using their memory and whatever things, surroundings, they may actually they can come to the conclusion that this has been occurred, right? Suppose if we have one person has been dead, consider, can you are able to say a person as dead in a room, and when you see through a person, if there is a bottle there, so everybody automatically will adjust that there's a, yeah, drunk suicide, had done some suicide, you say some poison. So you will always will at once you will try to match that one. But when you go to computer, it find it's difficult there, right? So one thing, computer can be better at easy things, but when you are going for harder things, now only it's getting more or less as we are going for deep learning, or more or less some hard things can be done using this machine learning, right? So here, human vision can do amazing, like recognize people, navigate through optical obstacles. Suppose any obstacles there, so we can imagine. So slight things which can be seen from that, we imagine that that's the thing there. Yeah, apart from obstacle, there is a thing there like that. So we can understand mood in a scene, imagine stories, and still we are having lagging human vision lags from illusion. So ignores many things and don't care about accuracy of the world. So these are something that is accuracy and illusions which we'll never care when you're going for human vision, which is more considered in computer vision. Suppose if it's an illusion there, so suppose there's an image here, can you tell it's a young lady or a old lady, right? See here at one angle. So if you see this image, if you see like this can be considered a young person. At the same time, if you see this as a eye, we can have it as a old person. So the perception differs, right? So this is what illusions we have. So we have several illusions like 3D drawings, so we'll never able to understand whether it's naturally one or some illusion is there. And this one optical illusion. So actually, it's a form where you have two buildings which clearly shows you that looks like an eye. So that's an illusion there, right? And also, if we see a thing here, so here there is a prism, right? We are able to see. So there is a prism there, right? So, but if you give it to a computer, it's difficult. So they will say that there are 8 circles, right? But we are able to see. So inside in the circles there is a prism, right? So that's what we have. Object recognition is a main part in our vision. So that means is the we are able to this a fish or bicycle. So from the image you can identify what the person is. So by seeing, so suppose it's a shining edge, you can say whether it is slippery, right? So if it's by seeing if it's a thin surface, whether your weight will be supported there, right? So these are all the things. So how to build programs that can draw useful distinction based on the image property? That's a great mystery. So that's what we are going for in computer vision. So in image processing, most of the operation we studied in image processing are leading to this image, computer vision part, right? See for this images. So here in this image, if you load it to a computer, so the computer will say, so this how much pencils are there, what are the colors of the pencils, everything that computer will say. But the same thing, if when it is asked by to a human being, just seeing once, oh, they will find it difficult. So that's what the accuracy when the images with more details are there, the classification will be difficult in computer vision, but when you classify each objects, that will be a tedious one. So if the classification is done, then automatically it will give a clear idea about all the pictures, what are the things there, everything. But same thing when you see through our eyes, we find it even difficult, since we can recognize the object clearly, but we will never able to count how many objects are there and all. right? So that's all the major that is difference between computer and human vision. See, for example, this particular image. So, in this image, what is kind of image? What is this kind of image? We can say it as a some farmhouse like that, right? So, where are the cars and how many cars are there? We'll able to count. So, I am able to count three cars are there. So, you are able to see and where are the count cars there and how far the building is. So, this car is for the this white car is just nearby. It will be just 10 to 50 feet, and the car here it will be 100 feet from the building. So you are able to see, you are able to calculate how many far, how many distance, everything you are able to see, right? So you have to make the computer to understand. So I'll give you the different levels. From that we can easily understand. So for another example, how to detect the playground. So which type of playground is there? So the first one is football, second cricket. So it will be three looks the same for a computer. So they will say both three are, yeah, playgrounds only. But it is very much difficult for them to predict whether which one is playground, which one is cricket ground, and which one is tennis ground and all, right? So this is what computer vision will do. So what you do is physical 3D world will be there, right? 3D world means our ordinary scene. So you'll have some illusion, you'll give some light, and the sensors, what they do, normally light sensors will do. So you'll have light sensors to capture the image or video. So and it is given to a vision system, and the vision system, what that will do is it will describe the scene. Oh, this is what the scene is. So in short, what to do is, so this real cameras will capture the images. So this is the real scene of that. So it will capture the image. So from the image, it will try come to a conclusion. Oh, this is the model of that particular image. So that's what we want. So from the real scene and from the real camera captured that particular scene, you come to a conclusion, right? So using that particular real scene, so this is what the model is of that particular image. So that's what computer vision is, right? So when you are going for computer vision, so this will be the gentle block diagram, right? So we'll have image acquisition, image segmentation, image understanding, and for particular application, we'll go for, right? So when you're going for image acquisition, can be done with some cameras. So from using cameras, you are acquiring the image. So after that, we'll go for pre-processing. What you want to do is, if you want to do segmentation, whether we want to convert it into some RGB to some other plane, color plane, or some other. So if you want to detect the edges, which mask you want to use. So all this can be done within image pre-processing. If noise is there, you have to reduce the noises. So that will be done in pre-processing, and we go for main segmentation. So here segmentation differs. So here segmentation means you want to segment the object of interest. So we are going to segment the object of interest. It differs based on the application, right? Based on the application, you will segment the objects. If you want to have a face recognition, you will just segment the faces, right? So if you want to recognize an object, you'll try to segment that particular object alone, right? So first you go for segmentation. After that, you will go for post processing. Segmented image post processing will be fine tuning that segmentation. All right, fine tuning means whether if you are detected one object, some object may be overlapped with other object. So in that, what you do? So we can strike out that particular object, and you have to focus on this particular object. That will be all be done by this segmented image post processing. So after we segmentation, we'll give it to understanding. So in understanding, what you do is, so you'll extract the features, right? So you'll extract the features, right? By extracting the features, what you do is, so you'll get the, yeah, so if it's a facial recognition, so I'll extract the features like eye, nose, right? So from that, what you do, you'll go for classification. So from the features, you'll try to classify what the type of images. So whether that is yeah, yeah, this is a person, right? It's a that identification or classification will be done by this feature based classification. That's what we generally we call it as image understanding. So after that, we'll have the application specific feature extraction. So application will differ, right? We cannot have the same application everywhere. So according to the application, what is the feature you want to extract? All these things will differ. So I'll give you different levels of understanding, right? So different levels, so that it will help. It will help you where we are in computer vision. So here, the understanding covers, or understanding means all aspects of image analysis from low level to very high level, which is useful for recognition and interpretation. So we'll see from level 1 to level, I think level 7 is there. 7 levels are there. So before for going for levels, first you must know what is imaging, how you are getting the image, right? Straight away, if you get using a camera, if you are capturing an image, that image interpretation will be very much difficult. So if you are having an image, from that image, if you want to interpret, it will be very much difficult. So in that case, what you have to do is, you must know about what is the camera used and where the camera was. So what are the cameras used means, where this particular camera is this megapixel. Normally we'll consider in mobile, when you're going for mobile phone, we'll see 107 megapixel. So that megapixel tells you how many pixels are there. So if it is 10 megapixel means, so 10,000 pixels will be there. Pixel means that smaller picture element that we call it as pixel. So if it is 10 megapixel means 10,000 pixels will be there. When you are increasing the number of pixels, the clarity will increase. That's what in most probably in all the cameras, they are increasing the number of pixels in order to increase the clarity. Next one, light. So when you're capturing the image, so light must be clearly there. So if suppose if you are taking at night, so you'll never able to see objects clearly. In such cases also, nowadays we are going for night vision cameras are there, which uses IR cameras, infrared cameras, so that we can capture images. But actually, when you are going for daylight cameras, daylight, that is normal cameras, so how much exposure of light is there, right? Whether, so you know that every color will absorb different colors with the different ratios. For black color is that it will absorb all the light. So based on that, you have to classify. So you have to know this camera will capture how many brightness levels. So that will be equate to the so why we want to here is, and also final the color, which color we have, which color that we have, whether we are going for RGB or some other color formats. So why we need all this thing is, so without knowing all these things, we cannot come to a clear conclusion. So how much distance and what is the object is there, right? So for mainly for that only, we are going for this particular process of image. Yeah, that is physics of imaging, right? So next we'll go for, yeah, that is well level one. That is when you are using a single one image. Yeah, elevation. So I told you we'll go for level 7. So in the first vision, normally we'll go for detecting the corresponding, establishing a relationship between points. So that means the relationship between the pixels, one pixels and the next pixel. We'll try to have a correspondence between pixels. So if you do for different images, so the correspondence will be difference, right? So if there is any sharp edges, sharp change. Suppose if there is a change from, suppose if there is change from 0, so suppose a value is from 10, other value is 200, so there is a complete change there, 190, that will be the change. So normally for images it will be represented by 8 bit, so it will be having values from 0 to 256, right? So here based on the value difference or sharp changes, we are able to know whether there is edges are there. So from the edges, what you do is whether we can see what are the patches there, what is the texture there. All this we are able to get it from a image that is representing a image patch. So that is the important thing. So image locally looks like a pattern. So that it will get the derivative, that is it will get the pattern. What the pattern is? Just 1 minute. So it will give you the pattern in an image, right? So if you know the pattern in an image, automatically what we can get go to the next level. So that give you, so image looks like that locally, right? So consider this particular image. So this is what image is. So this is the image of a zebra. So and if you are giving a kernel like this, and if you to convolve this to convolve the image with this kernel, we'll get a output like this where you are able to see the edges clearly. So this is what is masking operation in image processing. So that you go for convolving this image with this particular mask, that is we call it as kernel here. So using this we are able to see the edges here. So next is edges means we can able to get the texture. Texture in that particular image. So the texture will differ. So the tigers, cheetahs, grass, trees, everyone will have different textures, right? So why you are going for differentiating the different textures in the images? So that one we can able to easily segment, and we are able to clue to a shape, what the shape will be, right? So that's what we have. So from the texture, what you do is if you are extracting the texture here, so see here the two things we have. So we are able to get the texture. Similarly, we have seen for a zebra, we are able to get the texture of these two images. From this texture, we are able to get the shape from the texture. So this particular texture can be grouped together. So this will be the shape of this particular texture. And this similar texture, if you combine, so we can get the texture of an object, right? So in the object, most probably the texture will be the same, right? So if you group all the textures, normally we get the shape of an object. So that's what we will do. We can easily extract the texture, right? So after extracting texture, we'll go to the next level 2. That is early vision in multiple images, right? So now you have got a shape, right? From the shape itself, we cannot come to the conclusion this is the object. If you have provided with a single image. So that's what early vision we use multiple images. So two or three cameras will get. So we know in our eye that is stereophysis. That's what we have it in our eye. So we'll use two eyes, isn't it? If you use two eyes to capture the 3D image. So you see, if you use a single eye, it's very much difficult to get a 3D of an image, right? So only when you are going for two images, just you do one thing, just close one eye and see an object. Then also we are able to see the depth. Then we can say with one image itself, I am able to get the depth, isn't it? So that is human vision. That is inside our brain. So everything will be mapped. So if you have an object like this, the object will be this much length and this much. All will be there in your brain. So when you have a single image itself, you will be able to detect it easily. But when you are going for computer vision, we're using a single images, it's impossible, right? So that's what we go. We go for multiple images, multiple cameras. So if you use multiple cameras, means normally we can get a 3D of an image, right? So that's what if you have a moving also, or if you have a single camera, you find it difficult for. So that's what we use two or three cameras, that is multiple images, right? Next we go for mid-level vision. So in the mid-level vision, what you do is, so you'll segment the images into small unit. So if it's a movie means, so it's a big unit. So we'll try to divide, right? Break images or video into useful pieces. That's what we go for segmentation. So we are going for segmentation means, suppose in a room one person moves from one place to another, right? Suppose a particular person moves from one place to another. So how will you know the person is moving, right? So what you do is, uh, first you try to segment that particular person. So after that, after segmenting that particular person, what you do is you'll try to track. So track where the particular person moves. That's what segmentation and tracking comes into play. In that's what middle level vision, right? So next we have go for high level vision. So in high level vision, what you do is we'll go for geometry based. That is relationship between object geometry and image geometry, right? So that is so you have a we have an object like this. So the object dimension is like this, and you have an image. So you know everything about the image since you know every property of that particular cameras, isn't it? So you know the property. If you know the properties of the camera, automatically will know every details of that particular scene, right? So that's what we'll go for model based vision. Model based vision means you want the position orientation of the known objects. That can be done. So then I'll outline the curves so what you do is what is the outline, that is whether you know what that particular object is, right? So you know the position and orientation. After knowing the orientation, you must know what that particular object is. That can also be done. And finally, the aspect graph. That is so, the curve is like that. So you know, how that particular object will look in different directions, right? And also how many distance that particular object is. That's the range data. So these are four things we can have in high level vision: border-based vision, smooth surfaces and outlines, aspect graph, and the range data, right? This is that will have the geometry. So one thing here, geometry means just the dimensions, dimensions of the object, surfaces, and how much distance. So how the object looks in different directions, right? So using that, we'll go for probabilistic. That is high level vision probabilistic. So this one where we'll go for, you will go for classifying and probability to recognize objects, right? So here we'll try to classify. So this object is this one. So and this object is this one. You will try to classify the objects. And after classifying the object, what we will recognize, we'll try to recognize. So using normally we'll use templates and classify. So templates means so this if object is this one. So this object template will be like this. So the and classifiers that everybody knows. Normally we'll go for a modern classifier like supervised and supervised classifiers. So we'll go for that also, right? I'll give you the just introduction for which one will be better, right? Next one, the relationship. So relationship between, so if you classify these are all the object present, then we'll go for relationship. How the each object. So in a particular object, so consider a bureau. So in the bureau itself, what do you have? We'll have different that is a grip, that is a different level where shelves will be there. So how the shelf structure will be, all this can be recognized. We will give a relationship between them, and from this relationship we will get a geometric templates for using some spatial relationship between the objects. So you are going for recognition and classification in this level 5, from the other 4 levels. And level 6 is the final one. Next one is based on application we have. Level 6, we are going for 3D construction from multiple views, right? So we have now classified and recognized the object. So in recognition also you must be sure that this is that particular object. So from the front view, it can looks like this is the object, but when you see the side view, it may differ, isn't it? The object may differ. So that's what we must construct a 3D construction from multiple views. So normally from stereo or moving. Suppose a moving picture means the if you you convert it into frames, and if you subtract the frames, you know the object which is moving, right? From that we can have, or what you can have stereo means from different angles, right? So if we have a photo, we can have construct a 3D construction. So strategy means you have to triangulate from distinct measurement. So of the same thing. So from the same object, we have to have a distant measurement, different distinct measurement throughout that particular. So from if we have a chair will be like this from the front view, side view will be like that, back view will be like that. All that must be knows. You must know, right? So from that only, that it will be the strategy. So this is the object, the general structure will be like this. So from that only you will try to create, right, the 3D. The so issue behind is, so if you are projecting to a 3D plane, the issue may be whether from this particular image, what you want to report, what the information you want from that particular object, isn't it? So from the object we can have several reports. We can have whether to identify or whether to classify which type it is, whether that differs, and also whether we are able to get the accurate reports. So that also will have. That's what nowadays you'll go for accuracy measurement when you're going for recognition and classification. We'll go for accuracy measurement there. just to know that your 98 percentage accuracy is there. This particular report is 99 percentage accurate. So now likewise we are able to come to a conclusion that's much percentage, right? And finally, so level 7, some application in details. So find that what, so find images in large collections, image based rendering, that is find images in large collection means what that mean is, so suppose if in a classroom, I'll give you in a classroom, if you are having one image, classroom we are having one image. So we are having a camera there. So you are consider if you install with a fisheye camera. So that we can capture the entire classroom in using a single image itself. So from that, how many persons are there? How many students are there? We are able to count. And who are all the person present today? By use of face recognition, you will be able to recognize what are who are all the person present in a classroom. So that is not enough. When suppose if you are taking class, someone will be mischievous. Some what that particular student will do will try to make some noise, and or he'll do something there mischievous. So all this, when you do some mischievous, automatically you can know who that particular person is. In the spot itself, you can recognize if you are having a real time recognition there. So that will recognize that is the particular person, that is the student who is speaking with this particular person, that is the person who is making command or making some action. Everything, yeah, the particular teachers can easily monitor. So in future, it may come, and that is classroom monitoring system. So where we can have automatic attendance system, automatic that is any mischief, some student makes mischievousness. So that can also be done using this particular application. So that's the best way we can have it in a classroom itself, right? We can develop by ourselves. So far, by just you going for all these 6 levels. And rendering means you're creating from the suppose some of the image has been damaged, so you'll be able to render by yourself. You are able to create your own images. So from the old images, so nowadays we can see a person that is in 60s image, it can be converted into latest image with colors, which are all by rendering. So rendering means creating by yourself. That normally we go for 3D rendering technique. 3D rendering means you are creating the image by yourself using the information you have, right? So this some application we have. With this application, I'll just give you a clear glance of the 3 levels. So in the low level, what you do, you get the property. So this is an image there. So from the image, what you get, you can get the edges there, isn't it? In this image, so this is an edge. You are able to classify, right? So that's an edge there. And mid-level image, your mid-level vision, we go for grouping. So we'll try to group. Oh, this all this can be grouped together, right? So this there is an object and a background. Likewise, I am able to get in the middle level, that is grouping and segmentation. So after that, we'll go for high level vision where we're able to recognize. So first one, edges will do. Next, you go for segmentation. And third one, by grouping all the segmentation, we are getting that particular object clearly and can recognize it's a chair, right? So this is what normally we'll do it in computer vision. So first we'll do basic operation, next middle level operation, then we'll go for high level vision. right? So next we'll go for, so normally when you are going for understanding, so how to come to the conclusion, how to recognize. So it's a chair. How to recognize, right? So for that only we'll use several deep learning and machine learning techniques. I'll go just go for machine learning techniques. So in machine learning techniques, we are having about two types, that is supervised learning and unsupervised learning, right? So we have two types. One is supervised learning. Supervised learning means it will learn to predict an object from a given input. So first, you in supervised learning, you will make the particular system to learn. So first, what you do, you will go for training. So this is the object. These are the features of that particular object. And if the object features is like this is the output, right? So we'll try to train that particular network. So after training, we'll go for, what do you go for? Classification. So there in supervised learning, we have two, regression and classification, right? So first one, regression. In regression, what you do is, it's a statistical approach. So it gives you a relation between a dependent and independent variable. So enable, that is, so it gives a relationship between dependent and independent variable, and come to a conclusion or come to a prediction based on that. What are the things there? Normally, it will be used for predict stock market, right? Normally, we will have a real value. So if you give the input, this is the output. So it will give you the, so the today's stock market, the prediction will be like this. So take for instance our image that is computer vision. Suppose in a table, consider in a table there are 10 pencils are there. So using regression technique, we can count how many pencils are there. So it will tell you in regression, it tell you there are 10 pencils present in that particular table. So using regression, we are able to, in computer vision operation, we are able to get the number of items present in that particular image. Normally in a table, consider 10 pencils are there, it will give you 10 pencil. Next one, classifier. So it gives output in discrete class labels. So normally it can be used in character recognition. In real-time application, you can go for character recognition. Means in an image, OCR, object character recognition. So if you give an object, so this is A, this is B, like it will recognize the character and gives you, oh, this is a word there. If it is normally number plate, in number plate recognition system, we are implementing this one, character recognition, right? So here for our example, consider that you are in the table. I have 10 pencils, right? I kept 10 pencils. So I have in 10 pencils, four pencils are pencil in pencil, camel in pencil, four Natarajan pencils, and two some other companies one. So the even though 10 are pencils, the pencil structure will most probably the same, but the texture will differ, right? So from product to product. So what does the classifier do is, I want to classify how many Nataraj pencils are there, how much Camlin pencils are there. So this particular classifier, that is supervised learning, in classifier, it will classify. So there are four Nataraj pencils, right? And four Camlin pencils. Likewise, it will classify. So this is what the classifier will do. So in supervised learning, normally we'll have this regression and classifier, right? Suppose if a next type we have the unsupervised that is learning. So what do you have in unsupervised? What will you get in unsupervised learning? So earlier too, in regression and classifier, we are able to count the pencils and we are able to classify the pencils. Suppose consider in the 10 pencils, there is only 6 pencils are there. Remaining 4 pencils are the broken part of the previous pencils. Likewise, if we have, whether we are able to predict there in regression and classify, it's difficult. When you are going for supervised learning, unsupervised learning, it will give you a new idea about that particular image, right? I have to understand, give you a new representation of that particular image. New representation means I can in that particular 10 pencils, only there are only 6 pencils are there. Remaining 4 are the broken part of this 6 pencils, right? So that in unsupervised learning, you are able to classify like that. So that is, it gives you a new representation to an image. So you may think of the always why can't you go for regression and classifier or supervised learning? It's better, but you in addition to supervised learning, unsupervised learning is also important. I told you it gives you a new dimension of thinking, right? That's what yeah, most probably if you don't have any data about a particular object, in such cases the supervised learning will do that is, this is the object and this is the thing, a new object that is present there, right? So all this particular new idea about or new discovery about the new object will be done by using this unsupervised learning, right? So normally when you are going for computer vision, we know we need this three: regression also we need, classifier also we need, and unsupervised learning also we need. With this three only, we are able to go for computer vision, right? So now you may be clearly you must have understood in machine learning technique what are the things you can go for in computer vision, right? So as application, as for the application, we can go for whether we want to just want number of items there. So then regression will be better. So classify will be better if you know want different classify different objects, right? So and if you go for unsupervised learning, if you want to discover about the new discover about the same known thing in different dimensionality, so for that you go for unsupervised learning, right? So this one three things the supervised and unsupervised can be done in machine and learning, right? So now let me give some many examples where we are using this computer vision technique to extract different for different application. So 3D modeling. So now normally you must have in your Google Earth or virtual Earth. You must have seen in Microsoft Virtual Earth or Google Earth. So in that, in some cases I am able to see the 3D image of the street itself. Street, what are things object present there in that particular street in 3D images by just by moving the cursor. Just by moving the cursor, you are able to see what are the different things available in that particular town or city, in that street, and in a particular house itself. We are able to see. In most probably in several colleges itself, they are having this modeling. So that everybody can know what are things available in that particular college itself. We are able to recognize, right? So that is Earth Weaver. So the 3D modeling we have. Then OCR, optical character recognition. So where you are recognizing, where you are recognizing the different objects, right? So normally this object normally for best application is the number license plate, right? License plate when it's a moving object, moving car, automatically it had to recognize the number plate. So nowadays, oh, if you are exceeding a certain limit, automatically using wagon, yeah, receipt will come to your house. That is fine receipt. So this is what we have. You are exceeded limit speed, and driver is not wearing the seat belt. All this information comes automatically to through wagon or wagon, I think wagon website to you. So based on this license plate classification and reading object, what the particular number is. So then face detection. Normally, most of the cameras nowadays are equipped with this face recognition, right? So there, so in Google, Microsoft, they have different software, right? In Google, Microsoft, you have FaceNet, which recognizes the face. Likewise, most probably every software companies, they have different face recognition or face detection technique. Normally, Viola Jones algorithm only used normally used in most of the cameras nowadays. Viola Jones algorithm, which is used to detect the face. Then, so even though when you detect a face, from the face itself, we are able to see the recognize the mood of the scene, whether the particular person is smiling or is in which mood, that is whether he is angry. Everything will be able to see. And here, smile detection, that is this one, no, is in the camera, that is Sony CyberShot 170. It's a option there. It will click the, it will take photo when you are smiling alone. Otherwise, it will never take the photo. That's the option there. So when that is when the particular person smiles, it will take the photo. So that's the option there. So they just by recognizing whether a particular person smiles or not, right? Then object recognition in supermarkets. So in supermarket, the smart camera will be there, which watch you what are so basket will be there. In basket, what are the things you are kept in that particular basket? It will keep on monitoring that one. So when it monitors, after monitoring, automatically the bill also will be done. So after sometimes what you do, you'll tell you, I do not want this item. So you can just keep the item back to that self. That also will be identified. So at the end, when you go to the cashier, so he will tell you the bill. These are the things you have purchased. Straight away it will give. No need for billing there. So only one person will be there just to check whether these are the things that is present there, right? So that's a easy way we are used in normally lane hawk, where they use this particular evaluation robotics there in supermarket. So you must have seen this photography. So what the thing here is, so this particular who is she? Have you seen in that is probably in newspaper? You must have seen this girl, right? So this particular girl is Afghani, right? So what happened is a person Hawk, I think Hawk. So he had taken a photograph uh, in Pakistan in a army in a camp, that is In the camp, he had taken a photo of a small 13-year-old girl, right? So after 15 years, that particular reporter went to Afghanistan, right? So went to Afghanistan and he take the same photo, and he take the photo, and in that photo he happened to see the girl there who is now after 10 years, 23 years. So from that, he loaded on the computer whether to match. So at that time, he identified. So this for the same girl, which he took the photo in 10 years before in Pakistan, is the same girl who is there in Afghanistan now, right? So by just what you do is by recognizing the Irish by iris pattern recognition. Iris normally it is used in our that is Aadhaar card also. The Aadhaar card also we are going for the same technique, iris recognition, right? So using that iris recognition, she had got the that particular reporter has recognized that particular girl.
எப்படி
Yeah. Any any question is there? So if you want to have, you can go into net itself. If you try, you can get this photo and the story behind this one. Right? Nowadays, we are having this login without a password. So we have fingerprint scanner in our laptop itself and face recognition. In laptop also we have in that is in uh, most of the mobile phone. So iPhone and all, we are going for facial recognition for logging into that particular device, right? So login without a password. Then object recognition. So you must be using Google Lens. If you are using having Google Lens, using Google Lens normally when you have a cell phone, so there we can in Google we have if you open Google there will get a Google Lens at the side. So if you open that one and click to an object present, so it will show you this is an object, and it will show the similar object present in the world. So by that we can easily recognize several objects, or by this also we can compare. Actually, we don't know the one plant is there. We don't know what the name of that particular plant is. So if you use Google Lens, after you take the photo using that particular Google Lens means automatically it will show you. So this is the name of the plant, and this is what the details. Every details will come, right? So there we have it in Google Lens. Normally, it's available in most of the mobile phone, or now almost all mobile phone we can have. And special effects. So in Matrix movie, you must have seen the same face will be coming throughout. Every person will have the same face. So this come to reality nowadays in Chat GPT, in next level of Chat GPT. In Chat, I forgot the name, right? So in there, what you have to do if you paste in a video, when you paste this particular image person's, if you select a particular person's face and keep it there, then automatically it looks like that particular person is this one. The face itself will change. It will show there's a let's say a particular person where you want to from where. So suppose you are a person. Consider you are a person, so you want to make your dancing like that. So get a dancer who dances in a good way. Just you can click the face here and click the face there, automatically that particular face will be overlapped, and it looks like you're dancing, right? So that's the latest one in ChatGPT, right? So that is a paid version there in ChatGPT we have, right? Next we have the motion capture. That is, see here in the movie Pirates of the Caribbean. So you may see the picture like this, isn't it? See, in the top one is the picture. Actually, the particular person, what is he is wearing if wearing a headband. So headband will have some laser beams. So that laser beams helps to create an object around that particular person. So everybody, when from the outside, if you see, it looks like that particular object, particular person faces like this, the top. Actually, particular person faces only like this. He's just wearing a headband. So in the headband, what happens is there will be several laser beams are there, which are able to create an image outside. So using this only real time, we must have seen before in IIT Delhi. That is, they have done one, that is a graduation day. So it looks like everybody gets a graduation from the chancellor. They have created a video just by this one virtual reality, right? Next one, sports. Everybody knows. Now it's a season of cricket. So in the cricket, when you want to have replay for LBW, so what happens is they are tracking the ball direction, in which direction the ball will go, right? So all this are possible using this computer vision, right? So for that, this is normally used for most probably in almost all sports we have. I told you with reference to cricket and smart cars. So just I have seen that is Bolero, that is Baleno 360. So we are having a 360-degree view of the Baleno and the full version. I just my friend has bought. So from that I have seen. He has shown me the 3D view of that particular. What are the object present in 3D? It is in all the direction. Where they have only four cameras they had. For side looking camera, forward looking camera, and rear looking camera. From that, they are defined 360-degree view. So when you are taking reverse, you can easily say what are the on the four direction, all the direction, any object is there. You are able to see it clearly, right? So if you're having just a rear-looking camera, it will find you difficult whether any object is in the back, or when the particular person in the side cannot be seen. So when you're having the camera like this 3D view, automatically all the things around the car can be seen. So if you happen to see Baleno, the latest Baleno full version, we are able to see that one. Then vision-based interaction. So in DigiMask, we are able to. So you can are able to. That is in. You are able to use your image, your face. You are able to shift to a image there in the game, right? So that particular person looks like you. Normally, in can be used in gaming, so that you are only you are involved in that particular game. Then we have IR tracking build, that is multi-touch display. That is when you are going for interaction based vision based interaction. So we can use instead of having no keyboard, so keyboard will be there, virtually be there. When you press that, automatically typing will be done. everything will be done. And if you are able to, in a crowd, whether using a camera, how many persons are there, track the crowd. So these are some of the interaction in games. And in space, in moon, we are able to get the clear picture by just stitching. That is panorama image you must have seen. In most of the cameras we have panorama view, 360 view we can have. Just move the cameras, so all the images will be stitched to make it the single image. That's what normally used in robotics rover, which is used in moving in moon. So automatically, this computer visions only will make you to understand. So there is an obstacle there. So you have to move like this in this way. Everything will be done there, right? And medical imaging. So many new technologies has been formed based on this computer vision. So actually, 1 month before, I seen in a WhatsApp. So no need to diagnose. There's a device there. If you keep a person inside that device, the doctors can see 3D of every object, every organ present in that particular human being. They able to turn everything there and see the internal organs of every person, what the damage is, whether any person, what the thing has actual happened to that particular person. Every details can be seen virtually, right? So for that's all using medical imaging, and nowadays image guided surgery has been done, right? So all this occurred in less than 5 years old, isn't it? In just 5 years, in span of 5 years, you are able to see many things like this, right? And in the next 5 years, there are many active research scope here in this field of computer vision. Okay? So we'll see different application areas of computer vision: healthcare, agriculture, insurance, manufacturing, surveillance, sports, automotive, banking, in every sector, even in classroom, right? So in every sector, we are having this computer vision, right? So with this, I like to finish today's session since I have some urgent work. Actually, I'm not in a position to attend today, but unfortunately, I have some other work. So I finished session now. So if you have any doubts, you can ask for another 5 minutes, right? So anyone is there? So they may ask questions later to this one. In future, if time is there, in some other FDP, if time is there, I'll go for this Python with PyTorch. So where we can go for some real-time application using this computer vision. So you can see with the example. So no feedback or no questions from listeners.
Sir,
Yes, yes, madam.
create the session, sir.
Huh? So can we finish the session now? If any question is there, you can ask. Okay, I'll share the PPT with the host. Okay, so I'll share the PPT if you want.
As we come to the conclusion of this insightful session on computer vision, it's my great honor to thank everyone on behalf of Department of CSE, St. Xavier's Catholic College of Engineering. First, I extend my heartfelt gratitude to a distinguished resource person, Dr. C. Sildev Christopher, Professor, Department of CSE, SXCCE. Sir, your deep expertise, clean explanations, and engaging presentations have made this program exceptionally valuable. Your commitment to sharing your knowledge and experience has truly enlightened us and significantly enhanced our understanding of computer vision. Heartfelt thanks to all the participants for your active engagement throughout the session. Once again, thank you, Dr. Saldev sir, for sharing your valuable knowledge and insights with us. Thank you all.
Thank you. Thank you.
Dear participants, feedback link will be posted in the chat box. Kindly fill it for attendance. I request everyone to join tomorrow's session on time. Thank you.